Meetup. First time at the BTC with Kroger, so thank you, Kroger, for allowing us to be here. I also want to thank Engage Partners. They are a huge reason why we have these things happening right now. They help host at their location, and Leslie and Phil and Jamie, who isn't here, have done a lot to help organize this stuff, and it would not happen if they weren't part of this. And then lastly, I'd like to thank Traceable. So we have our guest of honor here, Inon Shkedy, and he's here to talk to us. He, if you don't know, is a co-author of the OWASP API Top 10 project. So we're here to learn a lot about that. And what else should I say? I think we're ready to get started. All right, thank you.
Hey everybody, thank you so much for coming to the meetup. Excited to be here. It's my first time in this part of the US, so also excited to get to explore Cincinnati. Today we're going to talk about the OWASP API Top 10 and about API security to understand new trends in the industry. And just before we start, I want to provide some background about myself. My name is Inon Shkedy. I'm a lead security researcher at Traceable. I got more than 10 years of experience in the field of application security, and I've grown up with APIs. So what does this mean? I started my career back in Israel. I used to be part of the red team of the Israeli army. And during this time, I used to break into the systems of the army and also like government system, financial and military. My job was basically to find vulnerabilities in those systems. And as you can imagine, very traditional technologies like ASP.NET, Java, and SAP. And the more traditional concepts in application development, such as multi-page applications, on-prem environment. And I used to see APIs, but it was more like a niche component, mostly for B2B communication. After 5 years in the army, I used to buy a one-way ticket and I moved to the Bay Area in California, where I've been working with startups and tier 1 companies. And I got exposed to a new type of technologies like Ruby on Rails, Node.js, Elixir, and new concepts when it comes to application development. Single-page applications, cloud environment, CI/CD, and the most important part is that all of these concepts are heavily driven by APIs. So APIs are not just like a component for B2B communication, it's the backbone of the application. And it made me understand that the vulnerabilities that I used to find back then in Israel didn't really apply to the new type of applications. And I had to learn very quickly how I can hack APIs and not just the traditional applications. And this is how I got into the field of API security. Just a few words before we start talking about the OWASP API project. I want to talk about OWASP as an organization. Who here knows like something about OWASP? You guys, cool. So basically OWASP it stands from Open Web Application Security Project, and the goal of this organization is a non-profit open source organization to educate developers and engineers about standards in application security, and also to provide free tools and guides on how to create more secure applications and how to learn about application security. Some of the most well-known OWASP projects are Mod Security, which is an open source web application firewall. Probably a big portion of the website that you use on a daily basis use Mod Security in some way. Many of the web application firewalls and application security products, they have a component that is based on Mod Security. Another tool from OWASP is Zap, which is a free open source scanner. They actually just left OWASP as an organization a few months ago, but this project started under the umbrella of OWASP. You have JuiceShop, which is an app that allows you to practice application security, and you can try to hack. It's kind of like a dummy JuiceShop app, and you can try to practice application security by trying to hack it. And then you have the OWASP Top 10, which is a list that the OWASP organization publishes every few years, and it defines the top 10 threats for web applications. So the reason why they do it is from the understanding that the the field of application security is very crowded, and you can find many different vulnerabilities. And if you want to educate developers or security engineers about application security, you can't just tell them about all the types of application security issues. You have to be a bit more focused. And this is why they create this top 10 list to define the most relevant threats for the last few years. So in 2019, I decided to start together with another co-author from Israel, who is the director of research at Checkmarks, if you guys know the company. We decided that we want to create a new list to address the top 10 threats for APIs. Because having just one top 10 list, it's not enough. Each application is a bit different, and now you have top 10 list for mobile security and also for API security. From the understanding that traditional application security vulnerabilities don't always apply to APIs. The first version was published in 2019. It got a lot of traction from Gartner, from different press organizations, and also you can find it today in many developer trainings. Many of the, if you like just look application security on Coursera, Udemy, or other companies that provide trainings, you would find that they have at least one module that talks about the OWASP top 10 for APIs. And also many API security products use the list to kind of talk about application security. But things have changed since 2019, and last year we created a new list. The creation process involves talking to many experts in the industry, to review many bug bounty reports, to gather statistics about different API breaches, and from this information to kind of compose a new list that talks about the most dangerous threat for APIs. As part of the process of creating the list, we had to, because like, why should you listen to me and Erez as to random people about API security? But the thing is, under the OWASP umbrella, so we got a lot of feedback from the community. We adjusted the list based on the feedback, and this is how we released the new list in 2023. I'm gonna provide you a quick brief of the new list. So let's talk about the different items. You have broken object level authorization. The first one is the number one. Then you have broken authentication, broken object property level authorization, unrestricted resource consumption, broken function level authorization, unrestricted access to sensitive business flows, SSRF, security misconfiguration, inventory blind spots, and unsafe consumption of APIs. So we decided to add a few categories in the new list because of the changes that we've seen in the market over the last few years. And also we decided to remove a few categories. For example, we see that things like injections become less and less common in APIs. Insufficient logging and monitoring is something that we don't find necessarily specific to API. It's a very important concern, but we wouldn't consider it as API security anymore. And we combined two categories and also expanded other categories. The next thing I want to do is to kind of jump into the list and to talk about the main trends in the list and to talk about different vulnerabilities. But before we do it, I want to talk about the biggest challenge in API security. And I think if you talk to any engineer, any pen tester about API security, they would agree that the biggest challenge in applications in API security is authorization. Authorization is the process of validating that one user has access to perform the action that they want to perform. And most of the API breaches that we hear about, they involve some aspect of authorization. And it took me a long time to understand why it's so difficult, why it's so challenging to create a decent authorization mechanism in APIs. And reviewing this problem, doing some research, I think my main conclusions, the main two reasons why authorization is such a big such a difficult problem to solve, is the first aspect of it is it's a very decentralized mechanism. if we talk about authentication, for example, this is something that you can do in one or few places in the code. You might have one dedicated team that is responsible for authentication in the application. When it comes to authorization, this is a shared responsibility of each engineer in the company. Every person who writes code, or even like just has the option to configure something, DevOps, software developers, they have some responsibility when it comes to authorization. If we talk about the object level authorization, this is something that has to be done in every controller that receives ID from the client and fetches a resource from database based on the ID, which basically means almost every controller in the code that talks to APIs. So it means that every software developer at some point is going to write a piece of code, or almost also like maybe just on a daily basis, to write a piece of code that would need to have those authorization checks. When we talk about function level, it can be done in the code, but also in the API gateway or the configuration level. So it's a very spread out problem, and it can happen, like authorization problems can happen in many places in the application, in the API. And if your company got breached because of authorization problem, it doesn't mean that you have a bad or a weak authorization system. It just means that one developer out of thousands or hundreds have made a mistake in one place in the code. So this is the first aspect of it. And the second aspect, I think that modern applications, they are much more complicated, also in the way that they design the policies among different users. So modern applications might have different groups and different hierarchies between the groups and between the users themselves. So one example that I like to give is just like some healthcare API, and you have different types of users. You have the patients, you have care providers, and then you have the admins. But then you can find like some weird examples. For example, the user Hugo that have some sub-users. So on my healthcare app, I might have the option to create a sub-user for my family, for my parent, for example. And then it leads to some weird situation that one user, by design, have access to the PII of other users, right? If I create a user for my parent, by design, I should have access to his information. But it makes it much more difficult, not just to code, not just like to code the controllers that needs to perform those authorization checks, but also just to define the policy from a higher level. And the second type of problem we can see is that you have one user that will belong to two different groups. Like Jack here, that is a care provider, but is also an admin. So even before we go to coding and configuration, just to define in a high level what is like the right authorization from like the policy perspective, it's much more challenging. And this is why we have so many authorization issues on the new list. Basically, we have 3 different types of authorization issues. Each one of them talk about different aspects of authorization, and we're gonna jump into each one of them. We have a broken function level authorization, broken object level authorization, and the new that we added to the new list, it's called broken object level property authorization. And I want to give you an example for each one of those vulnerabilities. And I'm gonna use Airbnb as an example. Just a disclaimer, I never found a critical vulnerability on the Airbnb API, not yet. But I think it's a good app to show you authorization problems, just because they have different types of users, they have different interactions between the users themselves. So the process in Airbnb, if I want to book a stay in a property, I need to request the host to stay in their property, right? And then there is a process that the host has to accept reservation, because a host might get different reservation for the same day, and they need to accept only one of them. So there is an API call behind the scenes between let's say that the host use a mobile app, between the mobile app and the API, of API call to API/host/accept reservation. And this endpoint, the responsibility of this endpoint is just to accept the reservation. What happens in broken function level authorization is, let's say that I'm a guest and I want to approve my own reservation, right? I just asked to book something, but then I access the API endpoint of accept reservation, and this, if the developers don't validate that the user actually belongs to the right group of host and not a guest, this is a Buffalo vulnerability, and this is something very common in APIs. And then the guest can approve their own reservation. which is something that shouldn't happen. In other cases that will be more severe is that a user might be able to access admin endpoints. For example, if you have an endpoint to like delete something sensitive on the app, and the user can access this endpoint, even though they are not an admin, this is a buffer. Then the second type of authorization problem we call BOLA. You might know BOLA as IDOR, Insecure Direct Object Reference. It's the same thing, we just decided to change the name. It's a vulnerability that allows you as a user to access objects that don't belong to you. So just to understand it better, on the Airbnb app, the host has to mention which reservation they want to approve, to decline or to approve, right? To accept or decline. But the problem is that they have different reservations that have been made on the same day, for example. So the client has to mention to the API which reservation they want to accept. This form of communication in APIs is done by sending the ID to the API. But what would happen if I just change the ID of the reservation that I want to accept to a different ID? Let's say from 919 to 915. If the developers don't validate that this ID belongs to my user, this is a broken object level authorization, and in this scenario, I might be able to accept reservations or to decline reservations on behalf of other hosts, just because there is no validation that this ID belongs to me. And I just want to stop you for a moment to let you know this is the most critical API vulnerability. Every API that I've tested over the last few years, I found a critical BOLA. Here is an example from Uber, for example. You know, Uber is a company that has pretty good application security standards, but then the security researcher Anand Prakash found this API endpoint that allows you to send a UID of a user. This is basically the user ID, and the endpoint returns information about your user. So if you send the ID of your own user, it's fine, because you should have access to this information. But if you change the ID to an ID of someone else, you would get the full information about this user. You can see this beautiful JSON object that contains all the information about the user, including like the phone number, the address, and also the most interesting part is the authentication token. So I could just change the ID to ID of someone else and to get authentication token, and it's basically full account takeover. Another example from T-Mobile, in this case, the ID is just the phone number. This endpoint receives the phone number, and if I change it to the phone number of someone else, I can just get full information about the client. So BOLA is a very common vulnerability. We can find big companies breach because of BOLA on a daily basis. Last but not least, it's the object property level authorization. Even if the developers did validate that the user has access to the function and also to the object itself, still we need to make sure that the user is accessing a property under the object that belongs to them. So if we talk about the Airbnb, you have a reservation, and then the reservation might have different properties. For example, comment or price. Some of the properties are more sensitive than others. So if the host, so we're talking about a host that is trying to accept and to edit a reservation that belongs to them. So they're not doing anything bad yet, but let's say that you have different properties that the host can access. One of them would be a comment, to leave a comment to the guest, or check-in is only after 11, or pets are not allowed, for example. So this property comment is not sensitive. The host should have direct access to the property. But then you have other properties that might be more sensitive. It means that the host shouldn't be able to access them directly, like the total stay of the price. Even though the user, the guest, had agreed to pay $100, and then the host can try to change the property to like $1 million. And if the API doesn't validate that this property should be accessed directly by the user, this is a BOPLA. And it can lead to this type of vulnerability. In this case, the guest would be charged much more. Any questions before we jump into the next trend?
Those examples you gave, how quickly did those companies respond to that, those, and fix them? Or did they? Yeah, yeah. Good question. Good.
Yeah, unfortunately, this vulnerability is closed, so we can't exploit it. I think Uber responded pretty quickly. They have pretty decent security posture when it comes to security incidents. With T-Mobile, I think it took them a bit longer to respond. But part of the problem is like to fix this type of issues, it can take a long time because you need to find the right team. Some of the this looks like more like a traditional API. Maybe the developer who wrote the API already have the company, and it's more scary to perform changes. Yeah. Let's jump into another fun vulnerability, unrestricted resource consumption. This is number 4 on the list. And this is what happens if the API don't limit the interaction or the resource that one user on the API can consume. It can lead to things that are a bit more, that's pretty straightforward, like denial of service. Like if you consume too much resources, you might cause denial of service. But also a new vector that we are seeing that becomes more popular is to increase the service provider cost. So it means that if the API doesn't limit the interaction, you might increase the bill of the company that you're attacking. So just to give you an idea how this type of attack would look like, talking about some API of some social network, and this API allows you to log in using a verification token. So you just enter your phone number, and then you get basically a text message with the token. And then using this token, you can log into the API. So behind the scenes, there is an API call to send verification token, and then the social network would send a text message to the client. The developers of the social network don't necessarily know how this protocol of texting works, so they just use a third-party service like Twilio that charges you by the SMS that you send. So if Twilio charges the social network 10 cents for one token, it's okay, right? It's not too expensive. But what happens if I'm as the attacker, I want to just repeat this API call of send verification token and to send it 10,000 times? Then the social network can, in a matter of like 1 or 2 minutes, be charged $1,000, and I can keep going with the attack. And this might look a bit like weird for you. Why would the API allow you to send this API call 10,000 times with no pauses in between? This is something very common. I bet that most APIs that you use, if you try to perform the same attack, it would work for you, just to send the token many times. The reality is that to define those flows, or like the API the rate limiting rules, it's becoming more and more challenging when it comes to APIs, and many companies just don't have it, or they have like a very vague rule. For example, they don't allow more than 1,000 calls from one user over a few minutes, but then you can just wait a little bit. It's not specific enough to the API endpoint and to the resource that the person is trying to consume. Another example how you can cause denial of service when it comes to APIs, and it requires you only one API call. So if you have a feature to upload an image, like for example, if I want to upload a profile picture to the social network, I can send a picture, and then the social network would try to create smaller versions of the picture. And this graphical process on the server, it's a very costly operation. It consumes CPU and RAM. But if I send just a normal picture from my phone, it's fine. The API can handle it. But then if I send a very big file, like for example, 1,000 gigabytes, it would make the API work very hard in order to create those smaller versions of the picture, and it can lead to denial of service. The next topic that I want to talk about is malicious bots, or how we call it in the more professional jargon, is unrestricted access to sensitive business flows. This is number 6 on the list. And what we are seeing over the last few years is that bots are becoming more and more dangerous. They're becoming more profitable for the hackers, and we see that there is a trend that bots usually decide to attack the APIs because it's much easier for them. Part of it is also because of bots just becoming smarter and more human using machine learning. one example that we can see is that for example, you have bots to write fake reviews, right? Let's say that you have a product on Amazon and you want to promote it, so you can pay someone to just post fake reviews on Amazon. And then to fight back, Amazon and other companies, they have teams to review the reviews. So if they see that the same review, like great product, like 10,000 times, they're probably gonna remove some of them. But now it's much easier to create fake reviews using ChatGPT. You can just ask ChatGPT to give you fake reviews that sounds human. So it's becoming also more difficult to find those bot patterns. And I think the most tricky aspect about bot protection, it really depends on the business needs. So one business might find a specific flow as sensitive while the other doesn't. And the detection requires, like, if you want to actually be able to detect and to prevent bots, you need to look at all the requests. You can't just look at one single request, as opposed to SQL injection, for example. You can look at one API call and to say this API is vulnerable to SQL injection, or there is an attempt to perform SQL injection or cross-site scripting. But when it comes to bots, based on one API call, you can't really tell this API call is malicious. You need to see a broader pattern, and this is one of the cool things that we do at Traceable. We just look at the business logic of the application and we detect those patterns. And I want to share with you a dilemma that we had when we created the list. It was, okay, we understand that bots are actually dangerous and they're very common in APIs, but how are we gonna name it? How are we gonna approach the problem? We can't just call one item on the list malicious bots. It's not the name of the problem. It's the name of the people who exploit the problem. So we got to the conclusion that the way that we want to name it on the list, the way that we want to approach it, after talking with different experts in the field of bot mitigation, is to kind of point at the sensitive business flows. So every time that you have a bot that does something malicious, behind the scenes there is a sensitive business flow that if you use it in an excessive way, by scripting for example, it would lead to something malicious. It's kind of like an interesting definition, and it also really depends on the business needs, because one company might find spamming as something malicious, while another company not. Depends on the business needs. And I'm going to give you a few more examples. So if you have the flow of purchase, you have the business flow of purchasing a product on some type of an e-commerce website like Amazon or eBay, by itself it's not malicious, right? But if someone manages to buy all the stock from the same product, basically perform this action of buying a product one after the other, and then buy all the stock and resell it for a much higher price, this is a problem, which is called scalping bots. Or if you have the business flow of posting a comment, but then one user can access this business flow and to create 10,000 comments in 1 minute, this is spamming. So the challenge here is that we can't just look at it as okay, we have a SQL injection. It's something that you need a much higher perspective on the system to understand which business flows the system exposed, and also to understand which one of them can't be accessed in a malicious way. And I want to go back to scalping. It's a very common problem that we are seeing in the e-commerce field. We could see it with COVID masks, PS5. What happens in scalping is that one malicious actor or a group of actors would buy all the stock from a high demand item like the PS5 or a concert ticket, and then resell it for a much higher value. And many companies are struggling to handle it. You can see this thing happen with Walmart, eBay, and many others. Any questions so far about bots?
Yeah.
Yeah, I think it happened with the Rolling Stones tickets. It's just one bot bought all of them and resold it for a much higher value. But I want to talk about the protection, and what you need to understand about the protection, it really depends on not just the industry, but also the business itself. So for example, if we compare Facebook and Twitter, both of them are social networks, they're kind of similar, but in Facebook, if you automate the process of creating a post, that would be something malicious. If you have a bot that creates many posts, this is something that they don't allow as part of the policy. But on Twitter, they actually encourage it, and you can use the API to create your own bots to tweet on Twitter. So this process involves two parts. It's first of all to define those business flows, and also to translate the business flows to the API calls that it involves. Even if we talk about something like purchase a product, we need to understand which endpoints support this business flow of purchasing a product. You might have 5 different endpoints that allows you to complete a transaction. One of them is used by the mobile app, one of them is used by the browser, and one of them is like an older version that you don't want to remove because you don't want to, you want to support the older clients. So once you decide that this business flow is more sensitive, you need to map it to the right endpoints. And after you do it, we can start talking about how we protect those endpoints that represent the sensitive business flows. The most basic one is just rate limiting. For example, to say, okay, one IP address can purchase the same item more than 5 times every minute, or like can't access the purchase item endpoint more than 10 times. And if you're an attacker, what would you try to do? You can just use a proxy. Every 10 times, you just change the IP address. So the sad reality about bot mitigation, there is no one right way to do it. Your approach should involve different parts, and some of them, like a bit more sophisticated than rate limiting, would be, for example, to restrict headless browsers. So if you see that you have an API call to purchase a product or to create a comment, but it comes with a user agent of Python, you're gonna remove it. And then the attacker was gonna try to change the user agent to something else that looks like a browser. So it's kind of like a mouse and a cat game. But there's other things that you can do. For example, to restrict the access based on the geography of the API calls. For example, if you only sell product to the US market and someone is trying to access this API from Europe or Australia, you can just block it. And then on top of that, you can do some human detection, like CAPTCHA, something that I'm sure all of you know very well. And the highest level of bot mitigation is to see the traffic patterns and to block abnormal traffic. So what does it mean? If I'm as the user, I want to buy something on Amazon. I just bought the Nintendo Switch. I wouldn't just go, like the process would be, okay, I'm going to go to Amazon, I'm going to look for the item that I want, I'm going to add it to my cart, maybe I'll spend like a few minutes on the website to review different options, and then I'll put my my shipping information, and only then I would complete the transaction. Which is kind of like, you can identify this pattern as something more human. As opposed to it, a bot, the regular bot would just try to go to your API, add the product to the basket, and complete the transaction in a matter of 1 second. They don't want to spend time. So you can actually look at the traffic and to build a baseline of how the normal traffic patterns would look for one business flow. And then if you see something abnormal, you can block them. And this is another cool thing that Traceable does. Once in your environment, we just start learning the normal activity with the API. And if we see that you have one attacker or a group of attackers trying to do something else, we would alert you or block the attacker. Numbers, how many more time we have? How much time we have?
You're good on time. We got another 24 minutes.
So let's talk about the next item on the list, server-side request forgery, which is number 7. What we're seeing in APIs is that many API endpoints allow you to provide a URL, basically an address of a resource, and then the API will try to access this URL based on the input that you provided. One simple example, I'm going back to social networks. If you have an option to upload a profile pic, there are 2 options. You can just upload the file from your mobile or from your computer, or you can choose the URL and the API would fetch it for you. This is a pretty common feature now that we can see in social networks. So what happens behind the scenes? Once I send the image URL, there's an API call to upload profile picture from URL with an API parameter of the URL. What would happen if I send a very large file, for example, to the API? If the API doesn't have protection against SSRF, they would just blindly try to fetch this resource. And if it's a very large file, the API will try to contact my evil server and to fetch this resource. And it can cause denial of service because the API would be too busy trying to fetch this resource. And I can also repeat this API call here like 100 times, 1,000 times. And basically the API would spend all the resources, all the CPU, all the RAM that they have, or even like the network bandwidth, trying to download a bunch of large files for no reason. And I can also refer them to like a server that doesn't even belong to me, just to find a URL of a large file on the internet. Another like cool things we can do using SSRF is not to try to make the API access a different API, but to try the API to access themselves. So in this case, you can see that I'm telling you, okay, my profile picture is on localhost 127.0.0.1 on port 22, which it looks funny, right? For us, it looks funny, but then if the API doesn't validate that the URL is legit, they would access themselves, and based on the response from the API, I can know as the attacker if the port is open or not. For example, if the API response comes back very quickly, I know the port is closed, and if it takes it some time, I know the port is open. And then this way I can map the open ports. It's kind of like internal port scanning of the API from outside. The same way, this is also another way to like bypass web application firewalls or just firewalls, because I can make the API scan the internal environment. So even if the attacker here doesn't have access to a service that would be here, I can ask the API to access this internal environment and internal IP addresses. Just like another cool thing is you can do using SSRF. And SSRF, it's not a new vulnerability, but it's something that we are seeing more and more in APIs. And the reasons for that, it's because we have features that are basically by design SSRF, like webhooks. When you tell the API where to access once something is happening, once there is a trigger, this is basically SSRF. Or like custom IDPs or SSO authentication environments. Those features just expose SSRF by design, and they also become more dangerous in APIs. Why? Because APIs, the cloud environment is more predictable, and if I have the option to provide an internal URL in a modern API-based application, it would be easier for me to exploit it and to know which API endpoints I should access. For example, I can access the cloud data, metadata provider like endpoint, and to get internal information about the server. I want to talk about number 10, which is improper inventory management. This is not like the sexiest vulnerability, but it's more like on the housekeeping side of the things. What happens many times that companies don't have visibility, or probably every company don't have full visibility into what assets they expose. If you have an API, or if you have microservices, you need to know what you have, what you expose, how you expose it, to who you expose it, and how do you stop exposing it if it's necessary, to have a plan how to redact it. And it might lead to blind spots or even blind areas if you don't have it. One very quick example, like you might have different microservices right here, and if the clients want to access them, they would have to go through the API gateway, which is great because API gateways provide another layer of security. They might provide authentication, encryption, and so on. But then one of the engineers at some point decided to expose this service tree directly to the internet. And then an attacker can just find it and access directly while bypassing all those important protections. Another example of improper inventory management of what you expose, it can lead to zombie APIs or orphan APIs. Each application security company might have different names for those things. But basically what happens here is that you have one bank payment API, and this API hosts different endpoints. So if you talk to the engineers in the company and you ask them, hey, what is this endpoint, like download transaction as PDF? So like, oh, this endpoint was developed by this developer like a few years ago, and here's the documentation, here are the parameters that this endpoint receives. So it's fine, they know about the existence of this API endpoint. Same about transfer money, because those are the more common endpoints. But then you take a look and you see, oh, what is this V0 legacy B2B export all users? And this name is based on a real endpoint that I found. And when I found this endpoint, I was talking to the developers, like, hey, what is that? And like, oh, we have no idea. Someone wrote it like a few years ago. The person left the company. We don't want to touch it. We don't want to break anything. And I found like a pretty critical vulnerability on this one, on the export all users. And the point here is that if you don't know what you have, you can't protect it, and attackers tend to look for those endpoints that they have no documentation. It's usually easier spots to exploit. Well, again, if you can just bypass sometimes you can just access directly the microservice or the API without going through the API gateway. Another aspect of improper inventory management is what you share. You need to know which information you share with your partners. For example, going back to the Airbnb again, you have the Airbnb API gateway, and then you have different internal microservices. But then there is another platform called Shkedy that allows you as an Airbnb host to manage your guests and like to maybe to send them like customized emails and stuff like that. They work together with Airbnb. It's like a partner of Airbnb. And as part of this communication, there is part of this partnership. There is a communication between the tax microservice to the Shkedy API, because the Shkedy API also helps you to do like taxes. So it makes sense that you would share some information, like that Airbnb would share some information with Shkedy about the users, because the user had agreed to it. But then what happens many times as part of these communications between two different internal APIs, too much information is being exposed. So it makes sense that I would send to the Shkedy API maybe like the user ID or the username, but why do I share the payment details with the Shkedy microservice? And because developers, in many cases, just to make the APIs easier to consume, they would prefer to just expose as much information as possible, not to choose specific ones, which makes, in many cases, make their life easier, but it makes it very dangerous. If you just expose like a full JSON object instead of like specific properties, you might share too much information. And many companies don't know about like what they expose to the partners. Like if I ask you, oh, do you know like which type of information you expose to partner X? Many times when I ask these questions, they don't really have like a very clear answer. And then what happens if Shkedy is being hacked? Do you know what is the impact on your users? So this is another like very common blind spot that companies today have in their APIs. So we almost at the end of the list. Number 10, unsafe consumption of APIs. Number 10. So what we are saying, like a new trend that we are saying, is that developers tend to trust third-party APIs from well-known companies more than the APIs that you expose to your clients. And it leads to weaker security standards when it comes to input validation, authorization, authentication, and so on. And I want to give you an example of how this type of issue might look like. And again, I didn't find anything on this website. It's just like a good example for a website that communicates with external APIs and maybe trust their information. So you have this Social Blade. This is a website that allows you to find, like, to see trends on Twitter, right? So if you think about it, this website has two components. You can access you can create a user to consume the information from Social Blade, which is consumer facing. But then on the other part, to get all these tweets, to get all the information, they need to have B2B communication with the Twitter APIs. It's kind of like internal communication. So this is how you should think about it. You have the communication between the client, the consumer, and your Blade. This is the Blade API. And many times, this part, developers tend to not to trust what comes from this path. So if I'm trying to inject, for example, a SQL injection and create something malicious on the API, using this malicious payload, the API would return to me 400 because, hey, this is not cool, you're trying to inject a SQL injection. But on the other side, this is what happens if I try to create a user on the Blade API, like if I just click here, register, this would happen. But once the API of Blade is trying to fetch tweets from Twitter, usually developers tend to trust these flows more. So there is an API on Twitter, the Twitter API of get top users, and the developers, okay, this comes from Twitter, I trust Twitter, so I'm just gonna consume it without any input validation. And I can just create a user on Twitter with the name of SQL injection, and Twitter allows it. And then it's very likely that this type of APIs like Blade would trust it as opposed to the consumer side. And one example, I'm not sure if you guys know this payload. Who knows what is this payload?
Okay.
Yeah, this is the log4 shell payload, a very common vulnerability in the log4j library. So using during the time of the crazy hype around the log4 shell, we saw many users change their usernames to this payload. And I'll tell you a secret, they probably didn't try to hack Twitter. Twitter wasn't vulnerable to log4 shell as far as I know. What they tried to hack is the APIs that consume information from Twitter. And this is a good way to see how this vulnerability number 10 is common. Because if you consume something from API like Twitter, you are more likely to trust it. How many more minutes do we have?
You got 10 minutes?
As long as you want.
So we covered the top 10 list. Do you guys have any questions before we jump into the next part?
I have that question right there. Yeah.
Why do? Yeah, so let's talk about injection. This is something that we got out of pushback when we published the list. People ask, like, for those of you who don't know, like, injection used to be a big part of the OWASP top 10 list for many years. Every version you can see injections. Usually it's around SQL injection. And we decided to remove it from the OWASP top 10 for APIs list. And basically, as part of the injection flow, what happens is that the developer would take the input directly from the client, from the query, and add it to a SQL query. What happens today is that developers tend to use ORM environments. It's less common that developers write native SQL today. And I'll tell you a secret, the reason why they do it is not because of security, usually, just because it's much easier to use ORM environments. And this is why we are seeing less and less SQL injection. It doesn't mean that SQL injections don't exist. We just use them less common in modern APIs. And like the new list, this is something that we published in 2023. We decided to remove injections then. On the 2019, we did have injections. So this is like the new list talks more about the more modern APIs. If you have API that were written like 10 years ago, you're more likely to find injections there. But in the modern APIs, it's less likely.
So, are there any like drawbacks to the ORMs, or do you like, or for this reason, do you recommend them?
Yeah, I absolutely recommend to use ORM. It depends on the type of ORM environment that you use. I think as rule of thumb, every time you use like a new framework, it's good to like look for the name of the framework and like best security practices, and to see what are the exceptions. ORM environments usually have the option to write native SQL. It's not very common, but if the developer needs to do something very specific, they might just call a function that allows you to write native SQL. So if you look at the code of an app, I would recommend you to find all the calls for this function that allows you as a developer to create SQL queries and to review them.
Do you think that so obviously SQL injection is not as high risk anymore than people leveraging ORM and things like that, makes sense. But what about like stored XSS and things like that, especially with APIs where they might not be doing that input validation,
Yeah.
and then that gets used on the front end somewhere else?
Yeah, that's a great question. And this is also, you can't find cross-site scripting on the list. And the reason why, it's not because cross-site scripting doesn't exist anymore. And again, the question is, what about cross-site scripting? So the reason why we can't find cross-site scripting today on the list, it's not because it doesn't exist anymore, it's just because it's not an API problem. If you think about it, APIs return JSON. They return raw data. They don't return HTML pages. Back in the days, the server would return you like a rendered HTML page, and the responsibility of the XSS protection would be on the server side. Once you fetch a resource from the database, or you just take something from the client itself, you need to make sure that you don't put it as part of the HTML page that you return to the client. But now it's not the responsibility of the backend engineers, it's the responsibility of the front-end engineers.
So you're focusing more on the sanitization versus the keeping it out of the database or the data model?
Yeah, and the protection for against cross-site scripting would have to be on the client app, not on the API. So if you have, for example, like React.
Well, yeah, I mean, if you're doing like in cross-site script, stored XSS is what I'm specifically talking about, where you have APIs, and so I hit the API, and maybe I store into that database the XSS, and now the front-end app is reaching into that database or
Right.
hitting another API to pull that information out. You're putting the effort not on the input of that XSS or that potentially insecure
Yeah.
string coming in, but you're focusing more on
Yeah.
sanitizing it on the front end.
But let's take, for example, like, let's say that you have an endpoint that exposes the top 10 users, right? With the username. So this endpoint, it returns a raw JSON. But based the way that usually APIs work, this endpoint can be consumed by mobile, by web, maybe by IoT devices. So the sanitization of this input, or for example, to perform some type of like URL encoding, it's not something that you can actually do on the server side, because you don't know how this input or output, how it's gonna like be reflected on the client side. The protection against cross-site scripting in between two different frameworks, or between like Angular or React, might be completely different. So in many cases, you can't even implement the protection against cross-site scripting on the backend. You would have to do it on the front end, just because the same endpoint, the same output would be consumed by different applications. Does this make sense?
Yeah, I don't know. I feel like there should still be importance put on doing input validation at API layers as well.
Yeah.
Because, I mean, a good example would be your username, right? So like,
Right.
you were able to put your username in. I'm sure that
Yeah.
communicated at some API, and yeah, that might have been okay for the API, but if they would have had proper validation,
Right. Absolutely.
username should not be.
Yeah, no, totally agree. And it's also like part of security misconfiguration that we have on the list, just like sanitization and validation of the input. But the protection itself, at the end of the day, like the last part of the protection would have to be on the client side. Let's see what else we have here. Another type of common type of injection is the shell injection. one use case of shell injection that we used to see is that when developers used to use kind of like CLI tools to perform some actions, and basically they would call a shell command concatenating input from the client. Today it happens less just because developers wouldn't use those CLI tools locally on the machine. It doesn't really fit into the modern API economy. Usually they would just use external libraries or external tools to do it. So there is not much area to inject shell injections. And I'm not saying it doesn't exist, it's just less common to see shell commands being called from the API itself. Yeah, so just a quick summary. The OWASP Top 10 for API is just one of many other projects. I think it's important to be up to date for the OWASP API. In general, the OWASP Top 10 for APIs, if you create or if you test mobile APIs, there is also the Top 10 for mobile. Yeah, it was a fun process to create the list. We got